Hello, I am Tamer M. Rosalik, and we are going to solve this tech innovators common case that types of components they have consumes different amount of powers, which is where they have their value of components, A 3 units, B and 6 watts of power, and they cost different. Each component costs different. And as a facility head of operation research, I am tasked to submit a memo to production manager to be on the most optimal decision of those components to meet the minimum requirement of 72 units of processing speed and 80 watts of power usage for the company's new smart device. Okay, so let's start at for step one. Let's declare our variables of the problem. So let's declare our A as component A, B as component B, and C as component C, and let's declare our Z as cost. So for step two, let's formulate our objective functions, which is the cost. So for A, component A, it costs 8, and for component B, it costs around 10, and component C costs around 12. So step three is let's move on to the formulating the constraints. So as we can see here, the company needs to meet the minimum requirement of 72 units of processing speed and 80 watts of power usage. So let's declare that the component A has 3 units processing speed and 6 watts of power. So process 6, and for B 5 processing speed and 4 watts of power and 6. And let's put the um constraints here that it shall not uh go over 70 units and 80 watts of power. So step 4, let's develop the primal problem. So let's put our primal problem here and our product A, product B, and product C, then their processing speed and power usage C, and their cost. And let's just put their constants in here, 72 and 80. Let us move to the step. Let's transpose the primal problem. So let's put the usage units in here, 3, 5, 6, and 72, and their constants. And for the watts is 6, 4, 12, and 80. And yeah, I made the actual mistake one. Sorry. So 12, their constants are 10, 8, 10, 12. Next is solve the dual problem as a standard maps problem, step 7. The dual problem is just copy the transposed problem here, 356 and 356. Dual problem C1 and C2 and C3, and the watts, the power usage, 6, 4, 12. And here are their constants. And let's just copy this. So for this, we just copy pasted this to here, and we added, as you can see, we added S1, S2, and S3. These are the um slack time, slack 8, 10, 12. And for step 8, formulate and rewrite the objective function. So here we can see the objective function and the 72 and 80. Let's just put the negative 72 here as it is negative, and z prime equals 0. Okay. So step 9, formulate constraints and rewrite equalities as slack var. Okay. Here. Here is the slack. And so for step 10, we are going to develop the augmented matrix. So let us copy the values in here. for U56, and let's just copy 72 here. And the variable, the V for 6, 4, 12, and negative 80. And for slack, we're going to do it like this: 1, 0, 0, as it is in the row 1. And for slack 2, we're going to put 0, no variable here, as S1 has it. S2 has 1, and move here. Okay, so next we're going to do the pivot point. To perform the loop in, first we are going to perform the operation so that the pivot column becomes 0, and the initial process is to do the same thing in second iteration. And then we are going to look at the values for the negative value. So since 80 has the biggest negative, we are going to highlight the V column, as you can see, guys. It's highlighted. And we are going to determine the pivot row by doing the ratio. So let's do it by dividing 8 and 6, and and then drag it down. So as you can see, there you can see the results. Okay. As you can see, we have determined the pivot point. And we determined the pivot row by finding the lowest ratio. So as you can see, the lowest ratio is 1. And then we are going to move to the first iteration. We are going to start here by 0, 1. As you can see, the ratio is 1, and we are going to put him in the row 3, as he is in the row 3. So we are going to use fixed reference on this. So 1, let's do 1, and then divided by 12. As you can see, C32, it is 12, and then put fixed reference on in between of C. So we're going to do this as well in here, but we're going to use the negative. So equals negative C31 as 4, and times it to C38. C38 is the number 1, and then add it again to its value, or I mean the 4, the number 4. So we're going to have the result of 0. You are going to do that for all of this, and you're just going to drag it all the rest of on the row. And then, as you can see, we have an error here, as we are going to divide again we are going to divide the 2 to 0, as it is going to function divide parameter 2 cannot be 0. Okay, so that's error. As you can see, we cannot stop here, as we have still a negative here in the first iteration. So we are going to start so as we said earlier, that we cannot stop in the first iteration, as it has still a negative value. So we're going to start by, we're going to use again the fixed reference on this. So 0 divided by its times B43, so, and then plus B36. 0, as it's going to, we're going, and in short terms, we're going to use the same what we did in the first iteration here. So we're going to drag it here, and then we are going to have these results. 37, 37. All right. And then we are going to take the values of S1, S2, and S3. So for S1 is 0, Okay, 0 and S2R is 10.67. We're going to highlight this so you can see clearly. 10.67 and S3 is 3.11. So for this, to get the total cost is I'm not sure, is equals 0. Wait. Okay. So we can see here my solution is times add times plus. Okay, so I'm going to show you 0. Here and time 0 times 8 add by the b time again the b c9 and c9. Okay, so let's add again from here and times again lastly here. So enter. So we have the result of 144.02.